Dot school presents laws of exponents. At the very basic level, an exponent is a simple and efficient way of writing a number multiplied by itself a certain number of times. For example, we can write 2 times 2 times 2, which is equal to 8, as this, which is read as 2 raised to the third power. The number that gets multiplied by itself is called the base, and the number of times it gets multiplied is called the exponent. Therefore, in this example, 2 is the base and 3 is the exponent. In general, we could say if there's a number x that gets multiplied with itself, and if there are n of these x's in the multiplication sentence, therefore this one's repeated n times, we could write this as x raised to the nth power. X is the base, n is the exponent. There are a few laws of exponents that are important and therefore you want to know about. The first one is, if we have x raised to the a, where a is a number, multiplied with x raised to the b, that is equal to x raised to the a plus b. So the exponents are multiplied if they're on the same base. And the reason this happens is because if you think about this one, there are a number of x's on this, x times x times x, a number. And similarly, there are b number of x's on this, x times x times x, b times. So if you multiply all of them together, you are having a plus b number of x's in the multiplication sentence. Similarly, if we have x raised to the a, this time divided with x raised to the b, which means x times x times x, a number of x's on the top, divided with b number of x's on the bottom. And if you imagine a to be a number that's larger than b, then you would realize that you could cross off the b x's from the bottom with b x's from the top. Therefore, the top still has got a minus b x's left. So this is going to be equal to x raised to the a minus b. Another good way to remember this is, division is the opposite of multiplication. So when they're multiplied, the exponents are added. When they're divided, the exponents are subtracted. Then we have this law that tells us that if there is an exponent x raised to the a, and that is raised to another exponent b, so essentially we are having two exponents. It means that you have a bunch of x's, a number of x's, and then another a number of x's, and that goes on how many times? That goes on b times. So you essentially have b groups of a each. Therefore, the exponents in this case are multiplied. Therefore, we have x raised to the a times b written as x raised to the a. If we have a x raised to the a multiplied with a different base, let's call it y raised to the a, the same exponent but different bases, it's the same as the product of x and y, x times y, raised to the 8th power. A number raised to the 0th power is always going to be equal to 1, provided that number is not 0 itself. You could easily derive this if you plug in a is equal to b in this rule. So a minus b becomes equal to 0, but a number x raised to the a divided with x raised to the a again, because we set a is equal to b, is always going to be equal to 1. Therefore 1 is the same as x raised to the a minus a, which is x raised to the 0. But you cannot have x is equal to 0 because division with 0 is not allowed. In the same way, if we use that rule, the division rule, to set this time b greater than equal to a, then we have x raised to the negative n, when negative n is what you get when you subtract b from a, is equal to 1 over x raised to the n. So all of the a x's from the numerator this time gets crossed off, but there are still a few x's left in the denominator because b is larger than x. And finally, if you have an exponent x raised to the m, and you take the nth root of that, that's the same as x raised to the m over n. So the exponent turns out to be a fraction this time. Let's see a few examples at work. Let's say we want to simplify 2 raised to the 10 divided with 2 raised to the 8. Now our division can be always written down as a fraction, the fraction bar acting as the division. Therefore we can go ahead and rewrite this as 2 raised to the 10th over 2 raised to the 8th. So this is going to be 2 raised to the 10 minus 8. In division you subtract the exponents, which is equal to 2 raised to the second power, which means 2 is multiplied with itself 2 times. 2 2's in the multiplication sentence, which is equal to 4. Note that we did not have to find the numerical values of 2 raised to the 10th and 2 raised to the 8th to get the answer. Here's another one. Let's try and find out the value of the expression 81 raised to the 3/4, which is going to be equal to 81 cubed and the 4th root of that. Now if you look at this 81, it can be split up or it can be broken down as a 3 times 3, which is 9, and another 3 times 3, 9 times 9 is 81. Therefore essentially we have 4 3's in 81, and when that itself is being raised to the 3rd power, take the 4th root of that, we have the 4th root of, this is 3 raised to the 4th, and that itself raised to the 3rd power. So we can go ahead and combine the 4 with the 3 and multiply them out. 3 raised to the 4th raised to the 3rd is 3 raised to the 4 times 3, which is 12. 4th root of that is going to be 3 raised to the 12 over 4, which is 3 raised to the 3rd power, which means 3 multiplied with itself 3 times, which is 3 times 3 is 9, 9 times 3 is 27. Let's say we have 3x, all of that raised to the 3rd power, times 2xy square, and all of that raised to the 5th power. We can rewrite this as 3 raised to the 1st times x raised to the 1st, all of that raised to the 3rd, times 2 raised to the 1st times x raised to the 1st times y raised to the 2nd, all of that raised to the 5th power. Now when we have exponents on different bases, we can split them up. So this is going to be 3 raised to the 1st raised to the 3rd times x raised to the 1st raised to the 3rd times 2 raised to the 1st raised to the 5th, which is this one, times the x raised to the 1st raised to the 5th times y raised to the 2nd raised to the 5th. Each one is an exponent raised to another exponent. Therefore, we should multiply the exponents. So this is going to be 3 raised to the 1 times 3, which is 3, times x raised to the 1 times 3, which is 3, times 2 raised to the 1 times 5, which is 5, times x raised to the 1 times 5, which is 5, and finally y raised to the 2 times 5, which is 10. This is going to be 3 raised to the 3rd is 3 times 3 is 9, 9 times 3 is 27. So we have a 27 times, bring this constant over here, 2 raised to the 5th is 32 times x raised to the 3rd times x raised to the 5th is x raised to the 3 plus 5 times y raised to the 10, which is 864. If you do 27 times 32, you get that, times x raised to the 8, y raised to the 10. That's how you simplify exponents.